All right, so today I'm going to do a quick kind of walkthrough of Atomic, and specifically I want to walk through the Git import and kind of trying Atomic, maybe from bringing in your existing Git repository. Maybe you want to keep those in sync for a little while you try out Atomic, and then kind of a quick show Atomic being used with a agent, recording your changes, your provenance, and all that kind of stuff. So just kind of a quick walkthrough of Atomic. So first off, we need to start off with installing Atomic. So you can find this on our website. You can also, if you want to go to atomic.storage, as a kind of a quick walkthrough of the basics of what to do. This is already installed, but I'm going to go ahead and run it anyways. First off, exactly as it says, you want to create an identity. This is much like your SSH key. This is what's used to sign your changes and kind of authenticate you whenever you do use Atomic Storage. So I'm going to go ahead and create this one. We're going to call this Aaron Demo 1. You're going to provide an email. Okay. So we've got our identity here. We're going to go ahead and set this as the default. All right, and then we're going to register our identity with Atomic Storage. So what this is going to do is it's going to go ahead and create basically kind of our account on Atomic Storage. This will let us create projects and push our code up, etc. So let's go ahead and, did not copy. Let's try that again. Copy, paste. All right, so we've now got we are here on Atomic Storage. This is our address here. So all of our projects will be under this address. So let's go off and let's create a workspace. So Atomic Workspace create. I'm going to call this one just demos. Basically Workspace is just like, this is a way for you to group your individual projects. So maybe you have like open source projects, or maybe you have like a certain group of project, like maybe a project that needs multiple code bases. So you could use a workspace to kind of help you organize those. All right, so let's go ahead and create a project. So I do have a code base in Git, on GitHub specifically, called Hello 2E. It's a Rust 2E. That's just a hello world. So we're going to create that project here in Atomic. That way we can import it. So let's do Atomic project create Hello 2E. 2E. We're going to create it in the workspace. Let's see, I called that demos. We're going to specify its kind as Rust, because this particular code base is Rust. Visibility, I'm going to set this to public. And I'm going to just give it a quick description of a hello world 2E written in Rust. Okay, so we've got a new project created there. Here's its URL. So if you were to want to give this to somebody else, they could use this URL right here and do a clone. But let's go ahead and grab our source code down from Git. Let me grab the repo here. So git clone, pull that down. So you can see here, we've got a couple commits. You can see this big commit up here. Yeah, spoiler alert. I tried the demo once and I misspoke, and I started all over. Cool. Fun of demos, right? So let's go ahead and bring this into Atomic. So right now here, it's just a Git repo, right? But since we have the Atomic CLI, we can run this command here. So we can run atomic git import, and this will go over all the commits and bring those into Atomic. So if we do atomic log here, we can see all the changes that have came into here into Atomic. So once you've done that, then you'll also want to do atomic git hooks install. So what this does is anytime you make a change through Git, maybe your muscle memory, you just went ahead and made a change to Git, and then once you pull that in, it's going to automatically come into Atomic. So let's go ahead and show that. So let me take a look at the README. So this is just kind of a quick one. Let me do to run this, use, and for some reason, all right. So you can see here, changes that. So let's go ahead and add README, git commit, add how to run the TUI to the README, doing from Git. So you can see here when I did that, the hooks fired and it brought that change into Atomic. So if I do an atomic log, I can see my my change recorded here. Let's just show that, doing that in Git or in Atomic. So maybe, yeah, that should be a double. Okay. So, we can see here, file is modified, atomic status, we can see that file is modified. So let's go ahead and record. Atomic, it treats, if you modified a file that you, or you're tracking, it's not gonna make you do an atomic add every time. If it's a new file, you will need to do an atomic add. So if you do atomic record -m, let's see, making a header, I don't know, from Atomic. Okay, all right. So then if we do atomic log here, we can see our change here listed there. You will see though, if you do a git status, that change has not been recorded. So get that represented here in Atomic or in Git. You can do an atomic git push that creates the commit, and that also then goes ahead and push it up to your branch. So if we do a git log now, we can see the atomic, the actual commit. These trailers here are used to help Atomic identify a commit and to be able to map back basically what has already been recorded in Git. Note, if you do a bunch of squashing and whatnot and it loses these, it will mess it up, which is one of the reasons why a lot of those that just bolt onto Git, like Provenance, are going to have issues, right? Because a lot of the commits change, contents of the commits could change. I don't know, it's just kind of a quick note. So let's go ahead and show the kind of the more agentic, intense Provenance and stuff like that. So let's clear that up. Yeah, let's. I could show this real quick. So earlier we did see the remote that we added. So if you want to actually hook your repo up, since we imported it from Git to Atomic, we can go ahead and push our code up to Atomic Storage. This was Aaron. I forgot. All right, Aaron, demo 1. Okay, so it would be Atomic, remote, add origin https Aaron demo 1.atomic.storage workspaces, we call it demos, and then projects hello TUI. So there is some shorthand, I believe, that can be used here that is coming out in a new version of Atomic. That should be out soon. But so you shouldn't have to type all this by hand. So this is added. So then, of course, you can just do an atomic push. And so that shoves all of the changes up to Atomic Storage, including any provenance. Right now, we don't have any provenance, and that's going to be recorded. But let's go ahead and let's go create some to have provenance. So let's do, we're going to use open code. So let's do atomic agent enable agent open code. And since I can't remember if I did this before on this machine, on this small VM that I've got running here, I'm going to go ahead and do that. You can see that it is cloning. So when it does that, it's bringing in the plugin from Atomic Storage. So it's bringing it from the Atomic org, Atomic Storage, and the OSS workspace. And this is the Atomic dash open code. You could grab that if you wanted to and go actually clone that and take a peek around. This is cloning it to a local folder here, and then it's doing the install. So it's installed the hooks into open code. All right, so let's go ahead and take a look into open code. Actually, take a step back. Let's do a cargo run. Let's actually take a look, see what our application looks like, so we can figure out what we want to change. So right now, that's pretty boring, right? Just a border, a hello world. Let's spruce it up a little bit. So, again, I'm jumping ahead of myself a little bit too much here. We need to bring in an agents.md. So right now we don't have an agents.md here. You could use to switch into atomic mode there in open code, but I like to bring in an agents.md. Just I don't have to remember to do that. So I'm going to go ahead and copy from. This is the path we just saw it bring in. There's an agents.md. I'm going to go ahead and bring that in locally. And then I'm going to do atomic add agents.md, atomic record, add agents.md. And then let's do atomic git push. So that's mirroring it over to git. All right, now let's go and let's go ahead and do a change. So, all right, we'll start off here. Let me actually show you that agents.md, just so you can see why that was interesting for us. So that shows basically tells our agent about Atomic. It's basically telling it to use the Atomic commands instead of Git commands. It's also telling it about how kind of in the Atomic process we want to start off with an intent and kind of the scaffolding behind an intent. Right, so we are using what's called shackle to do kind of like validation, so we can kind of give a little more guidance to the agent, as well as when we go back to do it, we can see if the agent actually finished all of these steps and met the criteria in kind of a structured way. And one of the cool parts about doing this is like models that maybe are kind of prone to forgetting things or to just kind of leaving things out and being lazy. This sort of like strict syntax format helps kind of when it goes back to the end of its turn to do this validation, it'll pop those things up that are not met, and it'll bring it back up in and just keep working on it. So that's kind of a nice thing. So that's basically what all this is doing, right? So this is just telling it kind of how to use intents. I was also telling it how to use memories and kind of the various rules. So that is kind of why I cared about the agent.smd. Now, all right, let's actually go in here. This is the third time we come in, so let's actually do something. So, all right, so that was boring, right? The actual TUI was very boring. So let's make our hello world TUI much more exciting. I want to add more color, and I want the hello world to be larger. Let's use some ASCII rendering and some color. It's not super specific, but this should be enough to get it to figure something out. So see there, it did a kind of quick discovery, right? Listed out the files, typical agent behavior, atomic status, and you'll see here now it's doing that TUI. Now that it's understood it, it's actually going and creating an intent. So let's see, it spit that out pretty quickly. So it's filling out the why, right? So it's kind of part of this template is we're forcing the why to be answered. We are forcing acceptance criteria, right? So running cargo run shows a TUI that renders hello world as large multi-line ASCII block art. That's what I was trying to remember earlier. I'm glad the agent figured that out. Okay, still quits cleanly, and cargo build clipping was passed without warnings, so that's good. So you can see here's an actual task for that, right? So we're actually breaking that down. One of the things that I really like about this is there's this file ref, right? So you can see what files it needs to actually modify as a part of doing this task. So that's kind of a nice thing to be able to kind of visually see. So there is also, it's in scope and out of scope. I find this also to be very useful. So this kind of forces the agent to maybe not be modifying things it shouldn't be, right? We're kind of saying like, hey, this is stuff out, making it think about that during this intent phase saves us some pain later. And see there's some constraints here, right? So that's also kind of useful to help it think about what it's working on. All right, so now it's going to actually implement. You can see there's the ASCII block. Cargo Clippy. Looks like Clippy must not be installed. Cool. All right, so build thought. All right, you can see here now it's going through. It's it's finished, so to speak. It got it to build. So now it's going through and actually modifying the acceptance criteria, right? Previously the status was unmet on this one. Now it's met. And you can see here it has verified by cargo build. And see this task. Status was unmet. Now it's met. Okay, this was met. Now it's done. Okay, let's just keep on going through here. All right, so here's kind of the summary here. Let's go take a look and see what it actually looks like. So let's do a cargo run. Cool. It's a little more exciting. Not a lot, but a little bit. All right, so let's take a look here at Atomic log. So you can see here is a change. Let's go take a look now at the provenance, because that's the exciting bit. So let's go ahead and so you can look at atomic change. So here by default we now spit out the kind of the full details of the atomic change. So here's the message on the change. This is something we do need to it's probably a bug because it usually shows something more descriptive than that. So you can see here's like the file, the graph edges, vertices that were changed, and the dependencies that change had. So this depends on the previous change that actually modified, the main RS file. So you can see a little more details of the number of hunks, etc. More importantly, though, here's attestation, right? So you can see the vendor, other open router, right? So we were using open router, that's correct. The model, you can see a GLM 5.2. The tool was open code. You can see the number of input tokens, output tokens, the costs. The session that we used here on the on open code, the turn, right? This was the first turn, so that's right. The finish reason was stop. So yeah, it came to a natural stop. Here's more about the actual change, right? Session change, nodes. Here's the goal. And this is kind of what the agent did, right? So it examined the files. It did an atomic status, right? Like we can see it edited, it synced, it created the file there. Right, so we can see kind of all the stuff it went through. And right, and then here's the actual full LLM response, right? The full okay, and now when you want to actually go and insert that in, so here's where you do an atomic view list, right? So you can see we create a dedicated view of the graph here, broad dust 2724. I usually do atomic switch or atomic view switch. Looks like our main right now is main. So I'm switching back to my main view, and then I'm atomic insert from view. And so now these changes are inserted into this view, right? So now we can see those changes in this view. So we do atomic log. We can see these changes exist alongside of our others. All right, and then if I do an atomic push, we can see it's pushing that. It's also pushing some provenance this time because we now have some provenance. So then if I do an atomic git push, we'll be able to see that change is now also in Git. So that was kind of a very quick demo into Atomic and kind of using agents to code with it, to record provenance, and kind of the power of intents. So hopefully that was interesting. Till next time. Bye.